Hello friends, welcome to our channel Technical Knowledge with Engineers. Today we are going to see some important MCQs on wave optics. So let's start the video. First is the phenomenon of redistribution of light energy when there is superposition of light waves coming from two or more coherent sources is called dash. And the options are diffraction, interference, reflection, attenuation. And the right answer is interference. Next is in destructive interference, the path difference between two reflected waves should be equal to, and the options are 2n lambda, 2n plus 1 lambda, 2n plus 1 lambda by 2, and lambda. And the right answer is option C, that is 2n plus 1 lambda by 2. Next is in constructive interference, the path difference between the two reflected waves should be equal to, and the options are 2n lambda, 2n plus 1 lambda, 2n plus 1 lambda by 2, and lambda. And the right answer is option D, n lambda. Next is the intensity of the wave is directly proportional to, and the options are under the root of energy of wave, square of the amplitude of wave, twice the frequency of wave, none of the above. And the right answer is option B, square of the amplitude of wave. Next is following is the method for obtaining interference pattern in the thin film. And the options are by division of amplitude, by division of wavefront, both of the above, none of the above. And the right answer is both of the above. Next is which of the following is the correct answer? And the options are ODP equals to mu into GDP, ODP equals to mu plus GDP, ODP equals to mu minus GDP, ODP equals to mu by GDP. And the right answer is option A, ODP equals to mu into GDP. Next is a film is said to be thin when its thickness is of the order of dash of incidence light. And the options are time period, wavelength, frequency, velocity. And the right answer is option B, wavelength. Next is the thickness of the widget shaped thin film dash away from the point of contact. And the options are remain constant, increases, decreases, none of the above. And the right answer is option B, increases. Next is in case of wedge shaped thin film, the fringes are dash. Options are straight, parallel, equidistant, all of the above. And the right answer is option D, all of the above. Next is in case of wedge shaped thin flame, the fringe width beta equal dash with increasing the wedge angle theta. And the options are remain constant, increases, decreases, none of the above. And the right answer is option C, decreases. Next is in Newton's ring experiment, the diameter of the dark ring is proportional to, and the options are under root of m, 1 upon under root of m, under root of 2m, under root of 2m plus 1. And the right answer is option A, under root m. Next is in Newton's ring experiment, plain glass plate is inclined at an angle of dash with respect to incident ray coming from the source. And the options are 45 degree, 95 degree, 180 degree, 25 degree. And the right answer is option A, 45 degree. Next is in Newton's ring experiment, path difference of the interfering reflected rays at a point of contact of the lens with a glass plate is. And the options are lambda by 2, n lambda, 2n plus 1 lambda, 2n lambda. And the right answer is option A, lambda by 2. Next is the coating of the glass lens is of suitable thickness of material which is used to suppress reflection from the lens surface is called dash coating. And the options are anti-reflection coating, advac coating, nickel, copper. And the right answer is option A, anti-reflection. Next is the diameter of mth dark ring in Newton's ring experiment is given by, and the options are under root of m lambda r, and next is under root of 2n plus 1 lambda r, 2 under root of m lambda r, 2 under root of 2m plus 1 by 2 lambda r. And the right answer is option C, 2 under root of m lambda r. Next is the thin film can act as AR coating if it meets one of the following conditions. And the options are the wave should have equal amplitudes, the wave reflected from top and bottom should be in phase, the wave should have different amplitudes, none of the above. And the right answer is option A, the wave should have amplitudes, equal amplitudes. Next is in Newton's ring experiment, if a white light is used instead of monochromatic light, then, and the options are the colored ring are seen near the point of contact, general illuminated is observed over the region, the ring will not be observed at all, the region will be divided into different color Vibgyor. And the right answer is option A, the colored ring are seen near the point of contact. Next is the optical lens of anti-reflection coating should be 1 dash of the wavelength, and the options are 8th, 4th, 3rd, 10th. And the right answer is option B, 4th, 1/4 of the wavelength. Next is a point source of light produces dash, and the options are cylindrical wavefront, plane wavefront, spherical wavefront, normal wave. And the right answer is option C, spherical wavefront. Next is an extent source of light produces, and the options are cylindrical wavefront, parallel to the wavefront, plane wavefront, spherical wavefront. And the right answer is option A, cylindrical wavefront. Next is the diffraction phenomenon is noticeable only when. Options are the slit width is large, the source is polychromatic, the slit width of the order of wavelength, and object is transparent. And the right answer is option C, the slit width is of the order of wavelength. Next is the condition for maxima for interference in thin film is, and options are 2 mu t cos r equals to 2m plus 1 lambda by 2, 2 mu t cos r equals to m lambda, 2 mu t cos r equals to lambda by 2, 2 mu t cos r equals to 0. And the right answer is option A, 2 mu t cos r equals to 2m plus 1 lambda by 2. Next is the distance between two successive dark or bright fringes is called as, and the options are angle of vidage, fringe width, apex, thickness of thin film. And the right answer is option B, fringe width. Next is for a better interference pattern, plane convex lens used in Newton's ring experiment should be, and the options are of large radius of curvature, small radius of curvature, very thick, very thin, so as to get proper rings. So the right answer is option A, of large radius of curvature. Next is in Newton's ring experiment, the thin fringe are coordinated away from the center, the reason is, and the options are the lens has small radius of curvature, monochromatic light is used as source, diameter of a ring is directly proportional to the square root of ring number, all of the above. And the right answer is option C, diameter of a ring is directly proportional to square root of ring number. Next and the last MCQ is the fringe of equal thickness are observed in the thin glass with edge of refractive index 1.52. The fringe spacing is 0.1 mm and wavelength of the light is 5893 angstrom. The angle of the bit edge is, and the options are 0.11 degree, 11 degree, 1.94 into 10 raised to the power minus 1 radian, 5.15 degree, 1.096 degree, and the right answer is option A, 0.11 degree. Thanks friend for watching, and if you think the video is helpful, please hit the like button and subscribe to our channel for more useful videos. And don't forget to share it with your friends and family. Thanks again.